All right, so how can I find the arc length of a curve given such as this one? It's not that big of a deal. It's not super hard to set up the formula if you remember what it is, but it may be a little hard to figure out the limits of integration. So if you remember your formula for arc length, you're always integrating from alpha to beta, and that's x prime squared plus y prime squared. You're taking the square root of all that and integrating dt. So x is this, so it's fairly okay to find x prime using the power rule, and same for y prime. And then setting it up, you just put everything into the formula, take square roots, and everything is going to work out fine. The only issue you have is finding the limits of integration. But if you read the problem carefully, it says you want to find the length of the loop of the curve. So that means our curve loops around itself. So if you were to sketch it, I'm not going to sketch it precisely, but I'm just imagining what's going to happen. So the curve is traveling, and at some point it loops around itself, and you want to find the length of just this portion. So what's going on, right? If you imagine that t is time, there's a particle on this path traveling, and then right here, at a certain time t1, the particle goes through that point, and then it continues to travel around the loop, and then it goes to that same point on a certain second t2. So there are two values of t. There's t1 and t2, and both of these values have the same x and y value, right? So different t's with the same x and y. If you can find those two t's, then you're going to be okay. You're going to know your limits of integration. So I'm going to go ahead and look at these and try and find two t values that give me the same y value and the same x value. So I'll go over these one at a time. So let's look at y first. Y is 3t squared, right? So I need to have t1 and t2 such that 3t1 squared equals 3t2 squared. You understand? I take this t1, plug into y, I get 3t1 squared. I take this t2, plug into y, I get 3t2 squared. So these two t values need to give me the same y value. If I cancel the 3's, I get that t1 squared equals t2 squared. And the only way for that to happen, for t1 squared equals to t2 squared, so one number squared equals the other number squared, is if t1 is plus or minus t2, right? But also, I have different t's. So t1 can't equal t2. t1 needs to equal negative t2. Okay. So these two times, they're opposites. It's either 1 and negative 1, 2 and negative 2, 5 and negative 5. So it's two t values that are opposites. This is the first hint that I got for my t's. And now I've only looked at y. Let me go ahead and look at x to figure out what else I can know about t. So if you look at x, again, I need t1 and t2. But now I know t1 equals negative t2. So instead of using them, I'm going to use t and negative t. I'm thinking t and negative t, so I'm going to go back into the formula and look at it. So got to be sometimes a little clever to figure these things out. So again, look at x equals 3t minus t cubed. I could just factor this out, factor t out if I wanted. And that will be 3 minus t squared like this. And again, you can see that you need to have the same t's. And then since 3 minus t squared is a factor that shows up here, what are two values that you know that have the same result once you plug in for t at 3 minus t squared? I know that if I plug in t equals the square root of 3, t minus t squared is going to be 0. But then if t is also the negative square root of 3, then t minus t squared is also going to be 0. So I have found two t values that when I plug in, I have x equals 0 for both of them. So my integration is going to be from the negative root 3 to the positive root 3. There's another way they can think about this, and you can also just go back and say, since you have t and negative t, you can plug in 3t minus t cubed and say that it has to be equal 3 negative t minus negative t cubed, just like we did over here, plugging in the t1 and t2, and then you can go back. You don't have to use t1 and t2. You can use alpha and beta, a and b, like is traditional for limits of integration in this unit. And either way, you're going to find them. You're going to solve a linear system, basically. Non-linear in this case. But from this equation, I can also find t equals root 3 and negative root 3, I believe. So let's go ahead and try it out. This is 3t minus t cubed equals negative 3t minus, or this time it's plus t cubed, correct? Double check this. Yes. Now this is going to come out this way. This is 6t. And this is going to come out this way. This is minus 2t cubed equals 0. And then again, I can factor out a 2t to get a 3 minus t squared equals 0. So I'd get values of t equals 0, of t equals the square root of 3, and t equals negative the square root of 3, because now that equals 0. So this is another way they can find those values, and then you check which of those also satisfy these for x. And of course, it's these two. Okay. So that is finding the limits of integration for the loop. All you have to do next, and let me move this down a bit because this is another problem I want to solve later. Let me go back. All I have to do is plug all of this into my formula. Okay. Let me copy this. Let me paste it here. Now I can just do the integral directly. This is an integral from negative root 3 to root 3 of the square root of x prime squared plus y prime squared dt. So that will be the integral. Let me go back to blue now. This is 3 minus 2t, all of that squared, plus 6t squared dt, and that will be the integral minus root 3. Root 3. Gotta FOIL this first one out. So that will be 9 minus 12t plus 4t squared, I believe, plus 36t squared equals all that dt. So you'll end up with a 40 in there. I wonder if this is where I need to use a trig sub. Let me move this further down a little bit. I think I have enough space at this point. So this is integral minus root 3 to root 3. It's the integral 40t squared minus 12t plus 9 dt, and I believe I'll be completing the square here. Isn't that correct? Let me see. Double check my calculations, see if everything's okay. There's a mistake right there. When I derived x, it should be 3t squared. So let me fix this when I FOIL. Maybe this is going to save a little bit of work. Save a little bit of work, so let's see. 3 minus 3t squared. Okay, that looks fine now. So this is 9 minus 18t plus 9t to the power 4. And this is 18t squared, actually. Does that look okay now? Okay, looks fine to me. And then now this changes into, oh, this is a lot easier than a trig sub at this point. So this is 9t to the power 4. And then I get to combine this and this. And again, this only changes from a negative 18t squared to a positive 18t squared plus 9. So that simply equals, same idea as before. This is the same thing as this, but with a change in the negative here. This is 3 plus 3t squared, square root still. Now, get to cancel these. There's always a chance that you're going to end up with a negative value in those integrals, but length needs to be positive. So you may avoid setting L equals 2 at the beginning. Just do the integral first, and at the end, if your answer is positive, you can say L equals that. But if your answer is negative, you say L equals the opposite. Just put the absolute value around at the very end. So this is not so bad. I can anti-derive this directly. This is 3t plus t cubed from minus root 3 to root 3. And now this will be 3 root 3 plus root 3 cubed minus 3 negative root 3 minus root 3 cubed, like this. So you get to say that this is, so this negative and this negative are going to cancel, but I think I can write everything as a power of 3 first before doing that. So this is going to be, so 3 is 3 to the power 1. Let me do this on the side here. 3 root 3 is the same as 3 to the power 1 times 3 to the power 1 half, which is 3 to the power 2 over 2, 3 to the power 1 half. So it's the same as 3 to the power 3 halves. So this becomes 3 to the power 3 halves plus, again, 3 to the power 3 halves. You have the power over power and multiply the powers now. And then again, plus 3 to the power 3 halves plus 3 to the power 3 halves. So you have 4 times 3 to the power 3 halves is the length of your curve. So that's how you figure out the loop issue and then go back to calculate the length itself. Now I want to solve this other type of problem. Let me get rid of this because I don't want to use this right now. I want to call your attention to this ds right there. So this s is the integrand, the thing being integrated over the formula in the arc length formula, and that is kind of useful. Whenever you have ds, that will be the derivative of the integral, right? Just think about the fundamental theorem of calculus again. Whenever you have length equals the integral of the square root of something, and you take the derivative, let's say this is changing with t, so from 0 to t. If you derive this, you go back to what you had inside, right? It's the fundamental theorem of calculus. The integral is the antiderivative. So you have this thing to begin with, you antiderive with this, and then if you derive again, you go back to the beginning. So that means the derivative of L is just this. And what's that saying? That's saying that this expression, this square root here, is how fast length is changing. And if you think of length as the distance traveled by a particle on top of that curve, going over that path that the curve describes, then this is the rate of change of position of the particle. So it's velocity or speed in that case. Speed because this is always going to be positive. And so in certain problems, you're going to be given a particle's path described in parametric equations such as these. And whenever they ask you for the distance, or excuse me, for the speed of the particle, you can just think of this ds right there. Say that speed equals the square root of x prime squared plus y prime squared. And that's going to be it. So if you go back and just do x prime being 2, and that's squared, plus in y prime, this is your y, being 4t minus 3 squared. This is going to be the speed of the particle. I can FOIL and expand this right now, but because the problem is specifically asking me about t equals to 5, there's no derivatives to be taken anymore, so I can just calculate these with t equals 5. So it's going to be a 20 minus 3, 17. And so I got to square 17. You don't have to know all squares. And 17, and 17. Is that correct? Does it look correct? Double check this for a second. So I'm doing 389 plus 16 right here. It's a 50145. Sorry, this is wrong, because 2 squared is 4. So it's not plus 16, it's plus 4 only. So this is plus 4. So I end up with 393. And I gotta take the square root of this. The book is showing that the answer is the square root of 293. But I believe that's incorrect, because it needs to be a little bit more than 17 squared. So let me check my math for a second. 17 times 17 does equal to 89. Oh, so that's the mistake I made here. Where is it? Oh, yes, this. This is a 1. This is a 2. So this is a 2 and a 2. Yeah, sorry about those mistakes there. And that should be approximately equal to 17.12 meters per second. So that should be the correct speed.